going on, guys? In this video, I'm going to be kicking off a series on Amazon AWS and cloud infrastructure in general. If you're interested in DevOps, infrastructure design, architecture, working for a tech company or working with a web application as an ops or infrastructure person, this will be very useful to know. Likewise, if you're just interested in cloud stuff in general and want to have a basic foundation so that you can kind of reason about it and start playing with it, this will also be a useful introduction for you. Now, I do assume that you have some basic sysadmin chops, like you should have experience logging into a remote server, working a tiny bit on the command line. This is really just going to be mostly focused on the infrastructure around that stuff, as opposed to a single system itself. But you absolutely have to be familiar with working on a Linux system. In this video series, I'm going to be doing, as always, mostly practical videos with some theory kind of peppered in, but some videos will be more theory or opinion heavy than others, and I'll try to keep those kind of isolated. So this will be a mostly like 99% practical video on actually getting a web application set up, highly available, and load balanced. We'll build on that and add more complexity as we go on. So we'll add a more complex web application that maybe has a PHP interpreter behind it and a separate relational data store, so something like MySQL. We'll break that out and talk about how you would go about scaling that. It obviously adds complexity to the configuration, so I don't want to just overwhelm you with that right away. I want this to be nice and gradual, give you some experience. When you log into Amazon, it's rough. I mean, they've done their best with the interface. This is actually the new version of their interface. But you can see, I mean, these are all the separate services that you can use. Most of this isn't intuitive in any way, like what's light sail? No one is born knowing that. You can't even really figure that out. You just have to start reading, start looking at documentation. So hopefully this will be sort of a gentle guide that shows you just the stuff you need to know at the beginning to make stuff work, and then you can always build on that. A couple of notes before we get started. First, you need an AWS account for this, so get an Amazon account and then go to console.aws.amazon.com. It'll ask you to sign up, so you'll get a free year of service for some basic things. Not everything we're going to do in this course will be free, so there can be charges associated with this stuff. Just beware of that. Also, we're going to be using the AWS GUI, the graphical user interface. It's brutally bad sometimes, but it's sort of the easiest way to get started. In practice, after you've been doing this for a little while and you kind of have some intuition around how AWS works, you're going to want to start using not GUI tools. So separate tools like the AWS API, which you can very easily work with. They've got an API command line tool. You can access it with something like Python and the Bato library. I myself prefer using a tool like HashiCorp's Terraform to manage infrastructure resources. So I really buy into the whole infrastructure as code thing, idea, movement, and that's kind of where you want to be going with this. But for now, I'm really just showing you the graphical user interface because it's easiest to demonstrate in a video. It is the easiest to kind of fail forward through. So like if you don't really understand AWS well, there's a lot of wizards in here and stuff where if you're doing this in the API or you're doing it with Terraform, you're just going to get errors and you're going to have to go troubleshoot that in kind of a more serious way. But here, you know, there's a wizard for everything. So you launch an instance and it makes sure that you have all the information you need. So it's just much more approachable this way. But again, later on, you're going to really want to use more specific tools like the API tool, the command line tool, and something like Terraform. I highly recommend you look into those, but just a little bit later. So again, our application requirements for this very first video are very simple. We're going to set up a very simple web server, Nginx, with like just a small static site. So these instances are going to be totally self-contained. We're going to stick a load balancer in front of that. And then we're going to create what Amazon calls an auto-scaling group. So this is a sort of set of servers. You tell it how many servers you want to start with, and you tell it you can grow to, you know, more servers based on load, and then you can grow back or shrink back down to less servers based on load. So it's something that helps you absorb load spikes that your application has to take. For example, if you are featured in a Hacker News post or something, you suddenly have, you know, 100 times your normal traffic or 1,000 times your normal traffic. Something that can allow you to scale and still stay up to weather these kinds of traffic spikes. So that's the very simple unit we'll be looking at in this video, how to set that up. And there's actually quite a bit of complexity with that. Amazon AWS, although it is often sold as being somehow simpler or I think more cost-effective than running your own data center, it's incredibly complicated, and literally running a data center is the only thing that's more expensive than actually using AWS. Like using managed hardware or virtual machine providers is orders of magnitude cheaper than this, but it's extremely popular for a few reasons, some good, some very bad, and you do kind of need to understand and know this if you want to be competitive in today's job market. Let that be my extremely warm recommendation for AWS. You got to know it, kids, so take your medicine. So from here, this is what you'll see when you log in for the first time. You're going to click on EC2. This will take you to your EC2 management console. EC2 is the Elastic Compute Cloud. Get it? ECC, but there's two C's, so they replaced it. You see what they did there? Because it's shorter. It's not even shorter. EC2 dashboard. This is where you spin up your virtual machines. If I just look at my instances, you can see I don't have any running here. I'm in the Oregon region. You will probably be placed in a different region. You'll probably be in Virginia, so that's US East 1. I've chosen Oregon, which is US West 2, just because I like Oregon. So we have no instances yet. We're going to want to launch a Ubuntu 16.04, whatever the latest LTS version is, VM. And the way we do that is by clicking Launch Instance, and then by looking at the AWS Marketplace. And what you'll see here is the first incredible failing of AWS, which is, how do you know who to place your trust in? There are some official images here, but there's also a ton of unofficial images, and it can be occasionally hard to tell where they're coming from, if they're up to date, what exactly they are. So what I recommend is you go to cloud-images.ubuntu.com, go to the locator web app, and I'm just putting in my region here. So if you're in US East 1, which you will probably be if you're in Northern Virginia, just type in your region name, and it'll show you the version. So we're looking for 1604 LTS. They're all 64-bit. And we want HVM Elastic Block Store SSD. I'm going to explain what that means in just a moment. So HVM stands for Hardware Virtual Machine. We're going to go ahead and just copy this AMI ID. So AMI stands for Amazon Machine Image. And that really just means these are the virtual machine templates, golden images, whatever, that you're going to be starting an actual virtual machine from. So if you search for this image ID, oh, sorry, it's a community AMI. See how wonderful this interface is? It's just amazing. I've been doing this for 5 years, and I still regularly just completely go the wrong direction in their interface. Okay, so here it is. Ubuntu images HVM, so hardware virtual machine using an SSD, so it's backed by an SSD. And the root device type, this is important, is EBS. This stands for Elastic Block Store. What that means is basically there's instance storage, which is something that is not actually backed by persistent storage. When you shut down an instance, that instance storage, it's like temp on your Linux machine. That thing is wiped on startup. So you're going to lose all of your state on that VM if you stop and then start the instance again. So you definitely want a root device type, so it's going to place the root file system on an Elastic Block Store. So it's going to be this is called an EBS volume. So this is an EBS backed virtual machine. Whew. Does that make sense? So you've got VMs, you've got these different kind of storage systems that they can use. They can use sort of temporary storage, which is called instance storage. And then you've got storage that's persistent, and you'll want to use an Elastic Block Store volume, an EBS volume. Okay, so we're going to go ahead and select this lovely AMI here, this Amazon Machine Image. And now we can go ahead and start thinking about launching our application server. So here are the instance sizes. So the instance type is basically how much resources do we want? They've labeled different kind of vCPUs and memory amounts with these names. So you can go ahead and choose, for like a larger real application, production application deployment, I would start thinking about choosing something like an M4 large, which is actually not that large. I mean, we're talking like 2 vCPUs, so virtual CPUs, and 8 gigs of RAM. Meh, it's like a small server, but it'll cost you. So we're going to use the free tier eligible, you'll see that, instance type, which is the T2 micro. It's very small, a single gig of RAM, 1 virtual CPU. But basically this is good enough for demonstration purposes right now. So we're going to configure instance details. Right now we're going to do everything in our default VPC, because getting into Amazon networking is its own video and it's just going to take way too much time. You're going to be crying, you're going to run away, you're going to close this video, it's going to be rough. You're not going to get anywhere that way. So right now we're going to run everything with sort of default networking settings, and that's fine for right now. Again, for production it's a different story. You really want to separate your, say, like dev, testing, and production into separate networks, that is separate VPCs, which are these private networks. You can think of it as like VLANs, basically. And then you've got subnets that you create for each of those separate VPCs. So you'll have some subnets that you create inside of your production VPC. You'll have some subnets in your dev VPC. And then your individual resources, like your database servers, your EC2 instances or VMs, they will be placed in those subnets in the appropriate VPC. And that just ensures that everything can't talk to everything else. It's like management nightmare, security nightmare that way, and it just allows you to do some network isolation. But we're not going to deal with that right now. Okay, so we want 1 instance right now. We're going to do this, but not right now. We will make this part of an auto-scaling group. We are using the default subnets setting for assigning a public IP. We do want a public IP address, so we can go ahead and connect directly to this server. So enable means please give this thing a public IP. We're not going to deal with IAM or Identity Access Management roles. We could create a new one here if we wanted. I also recommend you do that in production. When you shut this machine down, we don't actually want to terminate it, which would actually remove that instance and I think create a snapshot of the backing store and then remove the backing store. So we don't want that. We just want it to stop and then stay there so we can start it again. You can also protect against accidental termination. Don't worry about that now. We can also turn on monitoring, which is costly, but for production, obviously, you would want to do that. So we could turn that on. I'm not going to do that right now. It just gives you like CPU charts and whatever. Shared, obviously, is the default way we're going to run this. We don't want dedicated hardware because I don't have that much money. So let's add some storage. 8 gigs is fine right now. This is going to just give us an SSD volume here. You can choose from other storage types like the cheaper magnetic, but I think general purpose SSD is now free even for the Amazon trial. So there's no reason not to use it. It's just way faster than spinning platters. It's going to be mounted at dev SDA1. We only need a single volume. You could add another one here if you wanted another mounted volume somewhere and you wanted to put something on there. Right now, 8 gigs is fine. General purpose SSD is fine. And we can go ahead and start adding tags. So by default, we're going to want to add a name tag. We'll call this dev server. And that's where our devs will be doing their work on our application that we're going to be deploying. So great. Now we're going to configure a security group, dev server sec group. I should call it app server. So we're going to create a new security group. We're going to name it. You can give this a description. And then you can basically add firewall rules. These are essentially just firewall rules that work inside of your VPC to control what kind of traffic can get to a specific type of instance. This instance will have the dev app server sec group assigned to it. You definitely need a different security group for each class of instance that you're going to run. So for example, you have, let's say, an app server. Well, that needs to be available over SSH for your devs. It also needs to allow traffic on port 80 because it's serving a website. So we're going to add a rule for HTTP, HTTPS if you're living in this century, but let's not worry about it right now. And we're going to allow that from everywhere. So this is CIDR notation for the whole internet. You could restrict these things, like for example, you could restrict SSH to just your office IP or somewhere your jump host that your sysadmins use. But right now we're just leaving it open to the world because we're crazy. Like I said, this is probably going to be different for your app servers or your web security group than it is for your, let's say, database security group. If you've got a separate database server, you're not going to be allowing 80 in. You're going to be allowing probably 3306 or 4321 in. Or is it 5432? Man, I never remember what Postgres is. Anyway, one security group for each class of server you're running, essentially. And always err on the side of making more security groups than less. Can get a little bit messy, but yeah, you don't want too many things inheriting from the same security group, because then if somebody edits that, if it's called dev app server set groups, and someone's like, oh great, this just affects the app servers, and they add an inbound port or something, or they restrict an outbound port, if you accidentally have something else using that security group, it can turn into a big mess of like figuring out why something just broke that shouldn't have broken. So name these appropriately, describe them appropriately, and make rather more specific and granular ones than fewer sort of general purpose ones. Okay, we can go ahead and review and launch now. So this is warning us that we're currently allowing traffic on both 80 and 22 from the whole internet, and this could be bad. And it could be bad. But we don't care because this is just an infrastructure video. We're crazy. All right. So this is what's about to be launched. We can just sort of see a review of everything we've just set up. Our storage should have an SSH, SSD volume, not encrypted. Our tags, I think we only have a name tab. So we're good to go on this. So let's launch this bad boy. The first time you do this, it's going to ask you for a key pair. This is just an SSH key. So you're going to create a new one. And it's important to remember, this is the only time you're going to be able to download this key pair. So I'm going to repeat that. This is the only time you're going to be able to download this actual key file. So we're going to name it Tutorial Linux AWS series, and we're going to go ahead and download it. So this will create a key, and you can see we can go ahead and save that file. It's been saved, and we're going to launch that instance using that key pair. So our instances are launching. This will take a little while, and you can see your instances here. If we just click on this, you'll see that this instance state is pending. It's coming up, initializing. I'll be back when this is done. I'm really just going to get in there and set up a very, very simple website and then meet you back here. Okay, so we're back. We're looking at our development server. It's just finished coming up. And so what we're just going to do is go ahead and connect to it using this public IP here. So go ahead and select that. You can see the key name it's using is Tutorial Linux AWS series. So you really want to be sure that you downloaded that when you created it. We're going to head over to a terminal here. I believe that was placed in downloads. Indeed. So we're going to move the Tutorial Linux AWS series PEM to our home directory. SSH. I don't have an SSH directory. My God. I don't even have an SSH server. Jesus. Well, that explains it. All right. All right. We're going to make the directory SSH in our home directory. We're going to chmod that to 700. We're going to add that key. The move downloads, yeah. And then we're just going to check to make sure it has the right permissions. So right now, this key is actually, you'll see it's owner can read write, group can read write, and Everyone else can read. That is not nearly secure enough. So what we're going to do is chmod 600. We just want me to have read-write on that, and everyone else to have nothing. Okay, so now we've got an acceptable set of permissions on our SSH directory and on our tutorial Linux key here. And that IP that I pasted before, we can just use that to connect to the server now. So SSH, I'm not sure if it's going to be Ubuntu or root, so let's just, and you're going to use that SSH key. Let's see, so go ahead and accept the fingerprint the first time. Okay, and it's just telling us please log in as Ubuntu rather than root. That is good news. We probably don't want root open, although Ubuntu can log in and sue without a password to root. So we'll just change this to Ubuntu. And actually, one of the things we'll do is just add our key. Okay, so now you can see we've added the identity, so we don't have to constantly specify which key we want to use because it has a non-default name. So that's a listing of the SSH key we just added, or all the keys we've added to our little SSH agent. And now we can just go connect again. So we'll just try that SSH command again and just sub out Ubuntu. Okay. We're in. So what I'm going to do here is very, very simple. Normally you would go ahead and actually set this up. You'd secure this, as you may have seen in my securing SSH and doing key-based login video. I'm not going to do any of that because this is not an administration video about a single system. This is about the infrastructure surrounding this. So you do what you need to do to secure this server. I've made videos on that. And what I'm going to do is install Nginx and install, or at least upload, a very, very simple static HTML site. We'll get that working. So I'm going to fast forward through this bit and see you when that's done.